Welcome back to Applied Algebra and Trigonometry. We're going to talk some more about components of vectors, doing some application problems. For instance, let's look at an example of an airplane that is flying at 658 miles per hour, 20 degrees west of south. Well, first we have to establish what west of south means. So if we follow the convention that north is up on our page, then 20 degrees west of south would be approximately somewhere in here. Okay? North is up, south is down, and we're talking 20 degrees to the west. Because if north is up, we also have east, south, and west in these directions. So our question is, what are the vertical and horizontal components of the plane's velocity vector? We are dealing with the velocity vector. 658 miles per hour represents the plane's speed, and when you add the direction of 20 degrees west of south, you have magnitude and direction, thus you have a vector. So let's call this vector vector P. And vector P has a magnitude of 658 miles per hour. Note the units. We will be reporting them in our final answer. And a direction of 20 degrees west of south. That's not a standard angle. Let's find the standard angle. We start at the positive x-axis and we head counterclockwise through 90 degrees, 180 degrees, and another 70 degrees before we reach our vector. So our standard angle is not 20 degrees west of south. Our standard angle is 250 degrees. Let's resize things a little bit so this will be easier to work with as we search for the components. Okay, that looks like a good arrangement. Since we're letting this vector be called P, the magnitude is 658, we are looking for the x component of P, or P sub x. Let's make that a little bit bigger. There. And then we're going to be looking for the y component of P. So that will be P sub y. And that is a right angle there, in case you're wondering. All right, to find P sub x, we are going to multiply the magnitude of P by the cosine of the standard angle of P, the theta. So in this case, those numbers are 658 times the cosine of 250 degrees. And that will give us negative 225.949 ... Or, oh wait, how many significant digits do we have? Let's count. We have 1, 2, 3, and with 250 there is no decimal point there, so we only have 2. Therefore, we will express our answer with 2 significant digits. So our answer is negative 230 miles per hour. That is the horizontal component of our vector. Since we are expressing this with compass points, that negative 230 miles per hour is going in the westward direction. So that's 230 miles per hour west. Let's move this up a little bit. Now let's find the y component of our vector. P sub y will equal P times the sine of theta. All right, in this case, that is 658 times the sine of the standard angle, 250 degrees, and that will give us negative 618.317, etc., etc., which will round to 620 miles per hour. That is a negative. If you look on our graph, negative is south, so that's equal to 620 miles per hour south. Thus we have our P sub x component of the original vector and our P sub y component of the original vector. If you add those two vectors together, you will arrive at our original vector. Before we move on, let's think about something. How could you check those values? Move that back just a little bit. Remember that what you are working with is actually a right triangle. So what you have is a hypotenuse of 658, a shorter leg of 230, and a longer leg of 620. And when you're looking for the horizontal and vertical components, you always, or your x and y components, you always have a right triangle. And that's what we have in this case. So if this is a right triangle, it should be true that 620 squared plus 230 squared, equals 658 squared, because a squared plus b squared equals c squared. Let's see what happens. Now we did round, so it may be off slightly. So we have an approximation. That doesn't seem real close, so let's see what else we could do. Instead, let's put in the formulas that we were using to calculate each of those components. Let's see if we take 658 times the cosine of 250 degrees and we square the whole thing, plus 658 times the sine of 250 degrees squared equals 658. And I will post a short video of me doing that on your calculator so you can see exactly what you have to do to avoid an error there. So the left-hand side equals 432,964. And if you take the square root of that, you'll get 658. But if you just go from this expression and square it, you find that the two sides are equal. All right, let's look at a second example. So let's look at a Coast Guard cutter traveling 63 nautical miles at a heading of 30 degrees south of east. Note that this is not a velocity vector, this is a displacement vector. Nautical miles is a unit of length. So there's a graphical depiction of our Coast Guard cutter heading or traveling 63 nautical miles at 30 degrees south of east. So you're starting at east and you're moving your vector 30 degrees clockwise, which is not the standard angle. To measure the standard angle, we have to go through 90 degrees, 100 degrees, 270 degrees, and add 60 more degrees to that, making it a total of 330 degrees standard angle. If we let this be a vector c such that the length there is the magnitude of c, we can find the horizontal component of c, which would be here, and we can find the vertical component of c, c sub y, which would be there. So c sub x is equal to the magnitude of c times the cosine of the standard angle of c, theta. Okay, so here is our theta. In numerical terms, this is equal to 63 times the cosine of 330 degrees. Our original numbers each had 2 significant digits. Notice the decimal point there. So we will report this as 55, and we're looking at a displacement, a length, so the unit will be nautical miles. Let's do the vertical component. We're going to do c, the magnitude of our vector, times the sine of theta, that's the standard angle. So we will be calculating 63 times the sine of 330 degrees. And that gives us negative 31.5000, but we only can use 2 significant digits, so that will be equal to negative 32 nautical miles. Since we are expressing this in north, south, east, and west, these will actually become 55 nautical miles east, and though this is a negative, if we express it as south, we say 32 nautical miles south. You'll notice with each of these, we rounded the answers a good bit. So your check is going to be a little bit off unless you go back to the original trigonometric expressions and check those. So when you're working with vectors, it's best to get as many significant digits in your original measures as you can. But since it comes from your book, you'll just have to work with what you're given. Please use the units and the directional conventions, meaning north, south, east, and west, or up, down, left, and right. Whatever the original problem uses, please use that in your answer. And that concludes our application problem video. I'm going to do another video now on reference angles. Watch for that one.